Okay, so we'll do problems on Bernoulli equations this time. To start with, we have the following problem. The manometer fluid in the figure is mercury. Estimate the volume flow in the tube if the flowing fluid is first gasoline and second nitrogen at 20 degrees and 1 atmosphere. وتعطونا several fluids, okay? Then all we have to do is to check the change in density. And for different fluids, we have different densities. In general, in exams, or they give you directly the density, or they give you a table, and in this table, you can read values for different densities. Now, if we look at the following system, okay, we have a flow, and we know that as the flow is moving, we have a difference in reading between this level and this one, okay? And we want to compute what is the flow rate of the flow. In general, if you remember in manometers can help us to find variation in pressure. Okay, so if I compare this section to this one, I will have different pressure because of the variation in elevation here. Okay, and I know that I have a flow, so I can apply Bernoulli equation along the flow streamline. So let us try to write our equations, okay, and see how we can correlate the velocity of the flow and find the volumetric flow rate. So first we'll say that we will apply Bernoulli equation between this position, point 1, and point 2. Here we'll introduce, if you want, what we call the pitot tube. Okay, what is the pitot tube that we are illustrating here? The pitot tube is, as you can show in the figure, is a tube that can lead to deceleration of the fluid to cause the velocity to drop to zero because the fluid was moving in the duct. Okay, and suddenly, as the fluid will move through the pitot tube, it will be decelerated until reaching a velocity of zero. So whenever you see in a problem that you are using a pitot tube, you can directly say that whenever the fluid enters the pitot tube, it will be decelerated until reaching zero velocity. So you can say that automatically V2 is zero. And since we want to solve for the flow rate in this problem, we want to calculate what is the velocity of the fluid V1. So we know that because it's a pitot tube, V2 is zero, because it's a pitot tube, and V1 is unknown. So now we can say, let us write the Bernoulli equation between 1 and 2 in order to be able to calculate the velocity V2. So from Bernoulli equation, what do we know? From Bernoulli equation, we have P1 plus rho V1 square over 2 plus rho GZ1 equals to P2 plus rho V2 square over 2 plus rho GZ2. Now, since we have the same elevation for point 1 and 2, we can say that 1 equals that 2. So these two terms will cancel out. And because it's a pitot tube, V2 is 0. So we know this term. We still have to find V1 and delta P. To find delta P, what can we do? How we find delta P? Guys عم تسمعوني؟
Yes, doctor.
قطش شوي شي عندكم؟
مرقت شي 5 دقايق مش عم نسمعك.
طيب اوكي. وين يعني وقتها كنا عم نكتب البرنولي ايكويشن كنتوا سامعيني؟
وصلنا لنصها.
اوكي طيب. فاذا كنا عم نقول انه we considered the Bernoulli equation and we simplified rho g z1 equal rho g z2, and now we have the following relation. We have p1 plus half rho v1 square equal to p2. Now what is the second step? The second step is to find delta p. لأنه to find v1 we should find p2 minus p1. So by taking p1 to the other side, we can find that v1 is radical to p2 minus p1 over rho. But how to find delta p here? What should we do to find delta p? How we find the variation in pressure from one point to the other using the manometer? You remember in the previous chapter, all you have to do is to move within the fluid. Yani here, you have here a mercury. You have a fluid here. This fluid is mercury. And you have another fluid that is passing in the tube. You have another that is passing in the tube. Okay, so you can relate the two by doing this. So you say first, I have a fluid here. Okay, this fluid, if I
دكتور
start from point one, yes.
انا ما فهمت وين المركوري
ايه
بالمانوميتر، يعني هذا اللي تحت النازل
هيدا الريد. ايه الريد
اوكي
هو الميركوري.
وما
يعني انت الميركوري لك كيف كان؟ انت قبل ما نحط فلو، اوكي، اذا بتحط التيوب، اذا عندك نفس البريشر at point 1 and 2 بيكون الليفل of mercury the same for the two sides.
سيم
بيكون هيك
ليفل.
same level. اوكي، هيك كان الميركوري. بس قطع الفلو صار في pressure drop or pressure variation. اوكي، because of this pressure variation حيتغير الليفل of mercury. اوكي، لانه صار في difference in pressure between point 1 and point 2. هلا هون it's not a pressure drop, it's a pressure increase. Why? مين في يقول لي ليش هون the pressure will not drop, it will increase بالبيتو تيوب؟ انتو مش نحن قلنا البرنولي equation هي مثل conservation of energy للفلويد؟ نحن اذا بنكتب الايكويشن، اوكي، P1 هي الفلو energy at state 1، half rho V1 square هي kinetic energy at state 1. وبما انه ما في variation in Z between 1 and 2، يعني the gravitational energy or potential gravitational energy is the same. So what is just changing is the energy of flow and the kinetic energy. هلا as we said, when the fluid will move through the pitot tube, it will decelerate. يعني شو بيصير بالkinetic energy? It will be reduced. So you have the flow energy and the kinetic energy will, if you want, exchange energy. يعني will go from the kinetic form to the flow form. And the kinetic energy is being reduced. Because the kinetic energy is reduced, the flow energy will increase and P2 will be larger than P1. And since if you want the maximum possible pressure that we can reach هي لما تكون the velocity 2 0, because when velocity 2 is 0, we kinetic energy is 0, so we reach the flow energy will be maximum. So in the pitot tube we reach the maximum possible pressure at constant elevation, and we say it's called stagnation pressure. This is what we call stagnation pressure. Stagnation pressure is the maximum pressure of a flow when we decelerate it in without losses. Okay, we call it isentropic way. So in this problem, we know the velocity v2 is 0, and we want to find delta p in order to calculate v1. To find delta p, we say we have oil or here gasoline first, and then nitrogen, whatever is, we know the density of this fluid, okay, raw fluid, I will call it. And here we have mercury. So here we have raw mercury. Now, as we move down, okay, first, when we go from point 1 to point 2, first we should move down in the fluid, okay, and we can write P1 plus. Since we don't know this distance here, I will call it H, okay. This is small distance here, I will call it H. So you have P1 plus H plus raw fluid times the G times which height? We are moving down first the radius of the duct plus H, and the radius of the duct is given is 3 inch. Yani we have radius plus H. Now we are moving in mercury, okay? Because we are moving in mercury now, we can do jump across from this point to this one. And we can say that just we move from this point to this level, and here we do jump across because we are moving in the same fluid. And we will move down and then up in the same fluid. This will cancel out. How much we are moving? We are moving 1 inch, okay. هلا don't worry about unit, انتوا عادة بيجيكون as I units, يعني it will be given for you in meter. So here I will call this you can convert from inch to meter, so I call this T, let's say, okay. So since we are moving down in mercury, so plus raw mercury times G times T, okay. And then after this we'll move up into the fluid again, يعني minus raw fluid. Now what is the distance we are moving in the fluid? We are moving the thickness T plus H plus the radius, okay. يعني minus raw fluid times T plus H plus radius. And now we reached point 2. So this is equal to P2. Now, as you can see, we have we have here plus raw fluid GR plus H, and here minus raw fluid times H plus R plus T. So H plus R will cancel out. لأنه هون minus هون plus. So this term will cancel out. And we just have then that P2 minus P1 P2 minus P1 is equal to raw mercury minus raw fluid times GT. So all you need to know is the thickness, is the difference in elevation. If you just know T, which is the difference in elevation between these two levels, you can find delta P, okay? So you can read then from the manometer this difference. This is what you care about. We have seen that H and R will cancel out. You only care for this distance, okay? So now you can calculate delta P, and replacing back in your equation, you can find the velocity V1. Okay, any question on this? When you will take fluid dynamics, you will see that this device, which is called picotube, is used to measure velocities. Because what is the idea of this equipment? The idea is I can force the fluid to have a velocity of 0. So I can link the velocity V1 to the pressure variation because of Bernoulli. Okay, so this is this simple formula, which is V1 equal radical 2 delta P over rho, is the formula that will be implemented in the device to read the velocity by reading the difference in height, because delta P is proportional to this difference in height. Yani just for the device, okay? For the device, you just have to read this. Once you read this, you can calculate delta P. And once you calculate delta P, from Bernoulli, you calculate V. So all of this will be, if you want, يعني you can write a small program بالاكويبمنت اكيد بيكون في small program دغري بيعمل الايكويشن and it will give you the value of the velocity of the flow. So this is the application of this device. It's used for measuring the velocities of flows. Another problem. A neck-down section in a pipe flow called venturi develops a low throat pressure which can aspirate fluid upward from the reservoir. Using Bernoulli's equation with no losses, derive an expression for the velocity V1, which is just sufficient to bring reservoir fluid into the throat. What is the idea? You know always that a fluid tends to go from high pressure to low pressure, okay? So the idea here is by creating a certain like pressure drop between this point and this one, we can have like the fluid water here will go upward, okay? Because this will help. يعني here you have a pressure, let's say P atmospheric, okay? If you impose a pressure at this level larger than the pressure here, okay, this will lead to fluid motion upward. يعني انتوا بس تشرقوا مثلا ليش بيطلع الفلويد او الجي او حيلا شيء؟ لانه you are creating a pressure drop between the level of water, okay, and this level here, okay. The idea here is what is we want to find in this problem, okay, what should be the velocity v1 that is enough to bring the fluid to the throat. To be able to do the analysis and to see what is the relation between V1 and the fluid elevation in the tube, let us think together. First, we need to impose a certain pressure variation between this level and this level. What is the minimum, if you want, the minimum energy needed to reach this point? هي إنه we should provide the potential gravitational energy, يعني we should overcome potential gravitational energy. يعني نحن بدنا نقدر نطلع الفلو من هون لهون، okay? We should have the pressure here larger than the pressure here by amount of rho gh, okay? لأنه أنتم بتعرفوا إنه أنا إذا عندي إذا بتاخدوا حيلا example، إذا عندنا بناية، okay؟ وبدنا نطلع المي من تحت لفوق، ما فينا نطلعها بلا بامب، مزبوط؟ ليه؟ لأنه we should provide a pressure a high pressure at low level تقدر تعلي المي لفوق. هلا شو هو المينيمم required pressure؟ يعني تنوصل على القد، اوكي، تنوصل with zero velocity اذا بدكم لفوق. المينيمم يعني تيقدر يوصل المي لفوق بده مينيمم بريشر بطريقه انه دلتا بي تكون equal لرو تايمز جي تايمز اتش، اوكي. اوكي طيب and after this, okay, we want to relate this with the velocity v1 لأنه هن طلبوا منا نلاقي expression ل v1, okay. So first we'll say إنه here we have P atmospheric, this is P atmospheric and this is 0.1. So we have P atmospheric minus P1 is equal to rho gh. Now, How we link to velocity? To be able to link to velocity V1, we should do Bernoulli. And we know that we do Bernoulli equation along a streamline. Because we have the fluid here going from this level to this one, we can apply Bernoulli from point 1 here to point 2 here. What do we know about point 2? Point 2 is discharging the fluid to the atmosphere. So the pressure at point 2, P2 equals P atmospheric. Okay. And now, what about the velocity V2? We have here a velocity V2. Okay. How we can link V2 to V1? Look, I have V1 here, and the diameter here is D1. Okay. And I have here a larger diameter D2. How can I link V1 to V2? How can I find a relation between velocity at this section V1 and velocity at this section V2? What can we apply? نحن قبل برنولي شو تعلمنا؟ Continuity equation. What is the continuity equation? Here, conservation of mass. How can we write this? We have a flow, and we can write that m dot at section 1 equals m dot at section 2. And m dot is rho times A times V. So you have the density rho times area 1 times V1 equals to rho A2 V2. Rho will cancel out. So we can say that we can relate V2 to V1. We can say that V2 is equal to A1 over A2 times V1. And the area is pi d square over 4. So this is pi V1 square over 4. And this is pi d2 square over 4. And pi over 4 will cancel out. So we just have d1 over d2 square. So we can write that v1 is equal to v2 times d2 over d1 square. Okay. And now let us apply Bernoulli equation now between 1 and 2. Okay. So now if we apply from 1 to 2, from point 1 to point 2, the Bernoulli equation, we can write that P1 plus rho V1 square over 2 plus rho GZ1 equals to P2 plus rho V2 square over 2 plus rho GZ2. since we have the same height, rho gz1 and rho gz2 will cancel out. We have seen that delta P minimum to have water coming up is to overcome the potential energy here, the gravitational potential energy. So delta P should be rho gh, because we have already expressed. هلا انتبهوا هون، ليش فينا دغري نقول انه هي نفس الدلتا P؟ لانه P2 is equal to P atmospheric، لانه we are discharging to the atmosphere. Because we are discharging to the atmosphere, P2 is equal to P atmospheric. And we have demonstrated that we should have a difference in pressure from this level to this one, okay, to be able to have the water going up. And we have seen that PA minus P1 should be equal to rho GH. So since it's the same term here, because we have also P1 and PA here, so by taking P1 to the other side, we can say that PA minus P1 can be replaced by rho GH, okay? And taking V2 to the other side and expressing it function of V1 شو بيصير عنا؟ بيصير عنا rho over 2 times V1 square okay times 1 minus نحن قلنا شو هي V2 function of V1 هي V1 times D1 square over D2 square. Okay, so I can take into factors than V1 square. شو بيضل عنا؟ بيضل عنا D1 over D2. هي already square and now we are using square again. Okay, so بتصير to the power 4 لأنه square يعني بتصير to the power 4. Okay, so this is equal to rho GH. So now the only unknown in this equation is V1. So by taking 2 to the other side, 2 over rho will cancel out.